Shifting functions vertically. Graph the following equations by typing them into Desmos. So I want you to use Desmos or a graphing calculator to get a sketch of these functions. What is the equation of each graph? So a normal parabola would go over 1, up 1. This parabola has been stretched. Imagine you grab the parabola by the top and you stretched it up. So this parabola, instead of going over 1, up 1, goes over 1, up 4. Now, if I am stretching a parabola, I'm putting a number in the front. When you are stretching it, you are making it go up faster. So it's going to be a number greater than 1. This is the key right here. Over 1, up 4, the 4 goes there. And you can plug it in. If x equals 1, 1 squared is 1 times 4 is 4. So y equals 4x squared. Next, this one looks like at 1, we hit 0.5. We can't know for sure, but we are guessing 0.5. So y equals 1/2 x squared, or y equals 0.5 x squared. So this graph is going up slowly. It should be over 1, up 1. It should be over 1, up 1, but instead it's over 1, up 1/2. So this graph has been compressed. It looks like you pushed it down and squished it. It is going up slowly. This has been compressed. And the first one has been stretched. So 1/2 x squared or 0.5 x squared. Next, has this graph been compressed or stretched? Over 1, up 1 should be here, but it is going up faster. It has been stretched. It looks like we've pulled the graph up. It looks skinny, but it's really been stretched. So this number right here actually helps us to find the coefficient. Over 1, up 2. The vertex is on 0, 0. The only difference is it's been stretched. So at x equals 1, we plug in 1 squared is 1 times 2 gives us 2. So the coefficient of the parabola that has been stretched is 2. So now we have stretched the parabola and we have also moved the vertex. So we have a stretch factor of 2, x squared plus 1. So now we have compressed it, and it looks like 0.5. So we're going to estimate it to be 0.5. The stretch factor goes in front of the x squared. It is the coefficient of the x squared. But we also have a shift. This graph has been shifted down 1. So we subtract 1 from the end. So this graph, over 1, down 1. There is no stretch, but there's a flip. We have a regular parabola, which is a happy parabola, which is x squared. And if we flip it upside down, then that's a sad parabola, negative x squared. That is a flip. Y equals negative x squared. And then we have a shift of down 1. We subtract 1 from the end. Next, we have a sad parabola. So that's a negative x squared. And we have a shift. 2 to the left in the horizontal direction and 1 down. And there's no stretch factor. We can see that we go over 1, down 1. So we have negative. So horizontally, it moves 2 in the negative direction. So for the horizontal shift, we do the opposite. And we move 1 down at the end. Next, let's talk about the stretch factor. We know that it is a sad parabola, so we know that it's going to have a negative coefficient in the front, and we go over 1, down 4. Can you see that it has a stretch factor of 4? So y is equal to negative 4. We have shifted 1 to the right, so we do the opposite. We take x minus 1. So we shifted 1 to the right and down 1. So we subtract 1 from the end. This is a cubic. And you can see a cubic is supposed to go over 1, up 1, but it has been stretched. A cubic is also supposed to go down on the left and up on the right. This one has been flipped, and it has a stretch factor of 2. There's no shift. The center of the cubic is at 0, 0. The coefficient in front of the x squared, it needs to be negative for the flip and 2 for the stretch. Negative 2x cubed. Now, we do not have a flip, we do not have a horizontal shift, and we do not have a vertical shift. The only thing we have is a stretch of 3. So y equals 3x cubed. So what's the stretch factor on this one? Over 1, up 7. 7 is the stretch factor. Y equals 7x squared. Which operation flips the graph of a function over the x-axis? So the flip is multiplying the function by -1. Suppose that f of x is x squared and g of x is 5x squared minus 3. How do the graphs compare? So we have stretched it vertically, that's the 5, and shifted 3 units down. So how do the graphs of y equals x cubed and -4x cubed compare? So it has been flipped and stretched. Okay, so how about this one? The graph has been flipped because we see a negative, compressed because this is a fraction, and shifted 3 units to the left.